Okay, this next example is going to be a vectors problem example. And we're going to go from page 70, number 5, which says, graphically determine the resultant of the following 3 vector displacements. The first one being 24 meters, 30 degrees north of east. Second one, 28 meters, 37 degrees east of north. And the third one, 20 meters, 50 degrees west of south. So the first thing we need to do is sketch the 3 vectors that we have. So 24 meters at 30 degrees north of east is going to be like this. So we have 24 meters at 30 degrees north of east would be in this direction. We'll call that vector 1. Plus, the second one is 28 meters at 37 degrees east of north. So we're going to have one like this. It's 28 meters. And this angle is 37 degrees. And then the last one is 20 meters, 50 degrees west of south. So it's going to be something like this, 20 meters like this, and 50 degrees west of south is in this direction. Okay, so that's a sketch of our 3 vectors. First thing we want to do is determine what are we going to call the positive and the negative direction. So I'm going to use the usual convention of to the right and upward will be positive. Next thing we're going to do is take each vector and break it up into its components using trig. Okay, so you imagine each vector as being a right triangle with the vector as the hypotenuse. So this would be the x component and the y component. Okay, then this one, y component, x component. This one, y component, and x component. We'll make sure we draw arrows so we know which way we're going here. Like so. Okay, and then I want to set up a table. So I'm going to do x and y components, vector 1, vector 2, vector 3, and the resultant. Okay, so if I use trig to find the x component of vector 1, it's going to be 24 times the cosine of 30 degrees because it's the side adjacent to the angle. All right, so 24 times cosine of 30. And I get 20.8 basically. Okay, and then the y component is going to be 12 because it's 24 sine of 30. And the sine of 30 degrees is 1/2. So we get 12. Okay, for the second one, the y component is going to be 28 cosine 37. And the reason it's cosine, even though it's the y component, is because the y component is adjacent to the angle here. So we have 22.4 for y, 22.4. And for x, we're going to do 28 sine of 37. And we get 16.9. And for the last one, we get the x component, we're going to do 20 times the sine of 50 because it's opposites. And I get 15.3. And for the y component, I'm going to do 20 times cosine of 50. And I'm going to get 12.9. Now I want to check my signs because all I did was punch in numbers here to the calculator, but they're not all correct. Okay, the x and the y components of vector 1 should both be positive because the x goes to the right and the y goes up, so they're both positive. Same thing with vector 2. The y component goes up, the x component goes to the right, so they're both positive. The third vector, though, the x component goes to the left, so it should be negative, and the y component goes down, so it's also negative. Now we sum up all the x's. So 20.8 plus 16.9 plus negative 15.3 is 22.4. And we have 12 plus 22.4 plus 12.9, which is negative, sorry. Negative 12.9. We get 21.5. Okay, so now we use these resultant components, I should say, to get the resultant vector. The x component of the resultant is positive, which means it should go to the right 22.4, and I need our units per meters. And then from there, we're going to go 21.5 meters upward because y is also positive. So we have 21.5 meters. We want to find the resultant. Now remember, this is a right triangle, so we can use the Pythagorean theorem to find it. So 22.4 squared plus 21.5 squared equals, take the square root, you get 31.0 meters. So that's the magnitude of the resultant vector. Now we find the angle, or the direction, by using tangent. So what I'm going to do is the inverse tangent of the opposite side divided by the adjacent side. So what I'm doing is I'm finding this angle here. Okay, so 21.5 divided by 22.4, and I get 43.8 degrees. And this is north of east. So what I have is 31.0 meters at 43.8 degrees north of east.